Hello. Hi. Hey, everyone. Welcome to Node Interactive. Glad to see you all here. We're going to be talking about the JavaScript ecosystems. I'm Ethan Brown. I'm the Director of Engineering at PopArt. I'm going to talk a little about that in a second. Wanted to introduce myself. I did my undergraduate work at Virginia Commonwealth in math and computer science, my MBA at Portland State. I'm located in beautiful Portland, Oregon, and I'm the author of 2 books from O'Reilly, Web Development with Node and Express, and Learning JavaScript. For those of you who've read Web Development with Node and Express, you'll be happy to hear that I'm working on a second edition, which I hope to be out in Q1 of 2017. That whole technology space just changed so quickly, and it's in dire need of an update in such a short amount of time. So I'd like to give a shout out to my company, PopArt. PopArt's a fantastic place to work, and what I really love about PopArt is we're invested in JavaScript, we're invested in Node, and it's really great to work for a company whose vision is aligned with my personal opinions about the viability of JavaScript, and it's important to the web and open standards. So thanks to PopArt for giving me the time to come and present and prepare this presentation. So this talk was inspired by a humorous post on Hacker Noon a few years ago. I'm sure a lot of you read it. If you didn't, there's the link, and you're welcome to check that out at your leisure. And for those of you who didn't read it, I'll give you the brief summary. It was this fictional conversation between a developer who hadn't been in the JavaScript or web space for a few years and one who had obviously been keeping up in the trends in web development and JavaScript. And you can sort of imagine the hilarity that ensued. Someone who's using Babel, who's using Webpack, who's using React, who's using TypeScript, talking to someone whose last experience was jQuery and maybe the beginning of HTML5. So this is just a quote from that piece, sort of an example of the humor, and I love that quote about modifying states is equivalent to kicking babies, which I sort of agree with these days, and they give a little shout out to Elm and Haskell there. And what really struck me about rereading this as I prepared for this talk, because this was written a couple of years ago, is how prescient it was, or how relevant it still was, aside from a couple of details. They pretty much nailed everything that we're still talking about, we're still using, we're still struggling with. So I think it was a really well-written introduction. And like most things that are really funny, it was funny because it had a grain of truth, or maybe even more than a grain of truth. The JavaScript ecosystem has grown up. We're not just making tiny little interactive elements in web pages anymore. We're building giant applications in JavaScript. So of course it's more complicated. Of course there are more moving pieces. And so it's really just a natural evolution in JavaScript. Here's another funny little meme someone sent me that pokes fun at the size of the space we're in right now. So I'm breaking this presentation up into 4 pieces, and the last one may get short shrift on account of time, but that's okay. The first 3 pieces are really the most important. So my goal here is to help you all get a grasp on the size and the scope of the JavaScript ecosystem, and we're going to start with the big picture. And this is about being aware of all the things that are going on in this space, even if it's not your focus. If you're a web developer, it's still important to know what's going on in the Node space. If you're a Node developer, it's good to have a periphery idea about what's going on in IoT and so on and so forth. It just helps you connect ideas. And as you encounter problems that are at the intersection of different areas of expertise, having that general awareness will help you make connections, know who to talk to, know what technologies to look for. So I'm going to present a map of what I think are currently the most relevant large bits of technology in the JavaScript ecosystem. And before I show the slide, I know some of you are going to disagree with me. Some of you are going to be like, why did you leave out technology X? Or man, technology Y is so done. Why is that up there? This is just my opinion. We can all draw our own maps. And I know I've left some stuff out. So at the center of it, of course, is JavaScript. Now, we're at a Node conference, so you might think I'd be tempted to put Node at the center, but Node is really just an engine to run JavaScript, just like the browser. So it's a supporting actor in the play that is JavaScript. It's a very important piece of it, but JavaScript is really what binds all of these things together. So that's going to be the focus of my talk today. So let's explore this this web a little bit. So obviously on the web server side, we have Node and Express. Express being the biggest Node-based, JavaScript-based web server. There are other projects out there. There's Koa, there's Happy, but Express I think unarguably is the largest, most common one at this point. So if you're in the web server space, you'll know those projects. Then, of course, probably the second biggest audience out there is the web folks. People are actually building web applications. And the three big players on this stage are Angular, React, and Vue. React is my current personal favorite and the one I think that has the most chance and momentum despite the size of the Angular movement/community. If you're working in the web space, of course, the browser is a noisy, chaotic environment. You can't make any guarantees about the user agent, so we have to have Webpack, we have to have Babel to sort of smooth that and abstract away some of the details of the target environment, which is a luxury that we don't have on the web side, but we do have on the Node side. And this is the really interesting part of the graph to me. These are the languages other than JavaScript that compile down to JavaScript. And here we have ClojureScript, which is gaining popularity, TypeScript, which of course has been around for a long time. And if you like your languages typed, TypeScript is a great superscript of JavaScript. And then Elm is the one that I'm the most interested in. And of all the JavaScript-related languages out there, it's the one I'm most tempted to switch to if I decide to move away from JavaScript. It's a functional language that inspired React quite a bit. We have the IoT space. This is the one I know the least about. I've only done a little bit of piddling around in the IoT space, so I'm not really an authority on this, so I didn't want to try to call out any specific technology. I know there are a lot of network technologies like MQTT in the IoT space, but that's a big blob with a lot of different technologies, and I personally should be a little more aware of what's going on in there, and that'll probably be one of my projects in 2018 to learn more about that. Obviously, it's related to Node. There's a lot of Node instances running on micro devices in the IoT space. If you're in native development, either on mobile or on desktop, NativeScript and React Native, of course, are big, important projects, bringing that native performance, that native feel. I've used React Native. I think it's fantastic. If Angular is more your thing, you have NativeScript, which uses Angular by default. So we're moving into native space there. And then lastly is WebAssembly, and this is another technology that I'm really only peripherally aware of, and I'm definitely keeping my ears open because I have a feeling it's going to be big and it's going to be really relevant. For those of you who don't know, it's a subset of JavaScript that provides a compiler target for other languages. So if you want your C++ compiled to target JavaScript, or your Python, or your Ruby, or your C#, WebAssembly is where you would look. And it's basically allowing almost any language to target a browser or target Node. So it's going to have some interesting implications in the future, I think. So moving on from the big picture, let's talk about JavaScript, that piece that's at the center of our picture. If you want to be playing in the space, you need to know JavaScript, and you need to know it really well. Some of us have been using it for years, and some of us may not be aware of some of the new things that have come down. So this is the part of the talk that I want to try to give you something really useful, something that you can take away. So we have an interactive component. There's a website you can go to. I recommend you, I should have remembered that a lot of people bring laptops to this, so it's going to look ugly on your laptop. It'll look better on a mobile device. And what's going to happen is I'm pulling, the next 11 slides, I'm pulling out what I think are the most relevant or important things for you to know about the latest language features that have been introduced in the last 5 or 6 years. And if you're rusty on them, or if you haven't seen them, you can click on a button and you'll get a little more information about that in a personalized notes email that will get sent to you if you opt in. So without further ado, let's go to our first topic. I hope everybody here has at least heard of arrow functions. There are 3 ways that arrow functions fundamentally different from functions that are defined normally. 2 of those are pretty important and pretty significant. So if you can only think of one way, or you can't think of any ways, then I recommend you raising your hand like Hermione, our favorite overachieving student. Array spread and rest parameters. This is some syntactic sugar that makes it really easy to dynamically construct arrays. It also gives you the really fluid ability to call functions that take lists of arguments and use arrays in that. So this is something I see used quite a bit, and I think it's really handy. We have object spread, obviously highly correlated to array spread. It's a little bit newer. You have to make sure you have the right Babel configuration to use object spread. If you are confused as to why the example on the left says override and the example on the right says default, then you should probably brush up on object spread. My objective here is not to teach you about these things. There's just too much content here to do in a half-hour lecture. My objective is to make you aware of the things that I'm seeing that people are using and that are important and give you the resources to learn about them. Destructuring, obviously some more syntactic sugar, nothing you couldn't use with object property access, but it just makes your code a little bit neater, a little less verbose. So definitely know about this. If the second example there is confusing to you, you should especially brush up on it because I'm seeing more complicated use of destructuring that's been around for a while. I think people are just finally starting to get comfortable with it. Oh, and now you can hit that one. I'll give you guys a second since I was lax on the slide. I didn't have time to tie the slide API to the application, so I'm managing two things here. Computed property names. This is the one that I feel like is the sleeper hit of ES6. I don't actually see people using this very often, and I think they could use it a lot more. This is a fantastic little bit of syntactic sugar. It basically allows you to dynamically construct property names in object initializers or object literals, and I feel like every week I find a cool and new way to use this, and it works really great with functional programming. So if you haven't seen this before, definitely look it up. I'd definitely like to see more use of this in the community. We have promises. I'm sure most of you guys know about promises already. And although we're all using them, I would say promises are probably the #1 area of confusion among the programmers who work for me. So even though they've been using them for years now, it's still one of those things that in practice, even though the idea is very simple, in practice it can be really hard to get it right, and it can complicate and confuse debugging. So brushing up on promises is always going to serve you well. String templates, more syntactic sugar, nothing you couldn't do with string concatenation, but it just makes it more neater. It brings a feature that other languages have had forever into JavaScript. We love them. There is some grit and detail in there because we have template functions and we have, there's some handling of multi-line strings. So there's some details to know, but the basic syntax is really easy to pick up very quickly. Then we have async and await. I love async and await. Basically, it's bringing synchronous semantics to asynchronous execution. It's sort of combining the best of both worlds. It's making it a little bit easier to write our code and think about it and reason about it, and make it a little neater. We get access to try and catch again, which a lot of people were really dismayed that was confused by the introduction of asynchronous programming and promises. I will point out that there's a hidden danger in async and await. You still have to think about parallelism. You still have to think about your code. If you just write a function and you have a dozen awaits in a row, those are all going to run in serial. And if there's any part of those that can be run in parallel, you as the programmer are responsible for thinking about performance and being like, oh, those three things have no dependencies on each other, so I can run them in parallel. So you throw them on a promise all, and you're good to go. So do watch out for the performance consequences of overuse of async and await. Class fields. I'm not a huge fan of classical object-oriented programming in JavaScript. I think there are better paradigms in the JavaScript world, but it's still a useful thing to know. There's still enough libraries out there that are leveraging OOP. Even my favorite, React, uses object-oriented programming minimally, and they are very explicit that they don't want you to use inheritance as a code reuse vehicle, so they're trying to sort of constrain the use of object-oriented programming. But class fields are fantastic. If you are using classes, the ability to have class fields, and private class fields are coming. So within the next year or so, I'm sure there's a Babel flag that you can do it already. But public class fields are fantastic, and it really works great in React. One of the things that I've been frustrated, annoyed by React is this business of binding methods. So you can use them, class fields. If you assign a function to the value of a class field, you don't have to worry about that binding business anymore, which to me is the killer feature of class fields. A friend of mine made fun of me for including this slide. He's like, man, for of is so dead. Nobody uses for loops anymore. We're all functional programmers. We don't use control flow functions anymore. And I agree with him mostly. But if you are sort of making that transition from thinking imperatively to thinking functionally, and you're probably still using some control functions, you should at least be aware of the difference between for of and for in. Also, if maybe you're a little newer to the game and you're still using a for loop with index variables and you're not actually doing anything with that index, please start using for of. It'll make your life better, I promise. And then lastly, ECMAScript modules, or ESM. Again, here we are at a Node conference. Why am I talking about ECMAScript modules, not CommonJS, which is Node's flavor of module management? Well, Node is bringing in ESM. I think Node 8 even already has it. And my prediction is that eventually Node will deprecate CommonJS in favor of ESM, since it is a language standard. Now, I'm sure that's years away, if it ever happens at all. But regardless, it's important to know that there are competing, two different module standards you can use, CommonJS and ESM. If you're on the website, you're probably already familiar with ESM, not because browsers have support for it. Some of them do, especially if you're using a preview release, but because Angular uses it, React uses it, all the popular front-end frameworks use it and transcompile it into browser compatible. So those are the 11 things I wanted to highlight. I'm going to go ahead and end the interactive part of the presentation. So you should have a place where you can enter your email address, and we just lost. That wasn't supposed to happen. And a customized, personalized email will be sent to you if it works. I'm hoping that it works. I didn't have a lot of time to create and test this, so I'm crossing my fingers really hard here. And if it doesn't work, feel free to tweet at me or email me, and I will make it good, I promise. Okay, so I talked about the things that you should worry about, you should be learning, knowing, thinking about. Let's talk about the things that I don't think you really need to worry about. Generators, it's a cool feature of JavaScript. There are definitely some use cases for it out there, but the primary one, I think, was obviated by async and await. So, for a while, we were really excited to use Koa and generators so we could have that nice synchronous semantics with asynchronous programming, but now we have async and await. It's even better. We don't have to do it. So unless you're in one of those really weird use cases where generators make sense, I wouldn't worry too much about it. Symbols, another one, a great idea, a fantastic addition to the language, but A, I don't see people using it, and B, every time I've tried to use symbols, I run into nothing but problems with frameworks, with serialization, so I just sort of given up. I don't think the JavaScript ecosystem is ready for symbols, and maybe it's just not the right language feature fit for the things we're using for JavaScript. So I would wait and see on symbols. And again, object-oriented programming, I think there are better ways to accomplish the same things in JavaScript, better ways to accomplish code reuse. So I wouldn't, fret about learning everything there is to know about object-oriented programming if you're in JavaScript land. Okay, so I want to transition to talking about paradigms. There are 3 paradigms I want to highlight. So now we're not talking about specific technologies or language features, but how we use the language and how we think about things. So the 3 I want to highlight. The first is functional programming. You've already heard me mention this a couple of times. Not a new idea. When I was at university in the late 90s, we were talking about functional programming, and it was not a new idea then. So this has been around in academic computer science for a long time. I do credit JavaScript with being the first language that's really achieved sort of mass appeal and scale in people using functional programming. I think finally there's a sufficient momentum of people using it that we're all talking about it and being a thing. The normal criticism about functional programming is, oh, it's harder to understand, it's harder to learn. And I think that's really a matter of perspective. I think if we had all started with functional programming, the chaos and confusion and side effects of imperative programming would be the one that seems really weird and difficult to us. So I think it's just what we're used to. So if you've never really spent some time with functional programming, I really highly recommend you do it. JavaScript, of course, is a multi-paradigm language. So if you want to do functional programming in JavaScript, you have to employ discipline, because you can not do functional programming. If you really want to experiment with like really constrained functional programming, you can look at Elm, you can look at ClojureScript, or I'm sure any other number of languages. But you can do it in JavaScript today just by saying, all right, I'm going to have pure function. Everything's going to be pure function, and it's great. It's nice because you have no side effects. Side effects to me are the evil of programming. It's the worst thing you can have, and it's what makes our lives miserable. So functional programming just says, nope, no more side effects. I personally think you have better composability. Think about composing to functions versus composing to classes or to objects. Of course, object-oriented programming gives you a tremendous number of options for composability, but it comes with complexity and difficulty and all kinds of problems, and I think functional programming is just easier and more straightforward. And of course, testing functional programs is a lot easier and more straightforward. Then we have immutability. I think I skipped a slide. Yes, one-way data binding. So this is for the front end folks. This isn't really relevant to back end programming. This was an idea that was really brought to the table by Elm, and then it was picked up by Facebook with Flux, and then of course there was Redux, and I'm sure someone was thinking about it before Elm. And now it's in Angular, now it's in Vue. Everyone's starting to realize this is a really great idea. It really does make your application state easier to manage. When you first come to it, you think, oh gosh, this is just so much more work. There's so much more I have to write. It seems overkill, and a lot of people do feel it's overkill for small applications, but once your application reaches a certain size, it really does help. I also think it really encourages you to think about your application holistically, and I call this whole application thinking. When you have to think about the state of each piece of your application and where it fits into the component hierarchy, and you have to do that if you're using one-way data binding, then it really sort of constrains your thinking to your whole application, not just the part you're working on. And it's sort of an interesting dichotomy because it actually makes it easier to work on an individual part, but it encourages you to keep in mind the big picture as well. So I think it's really great for that. And I'm not saying one-way data binding is the thing that enables time travel debugging, but those two are pretty correlated. And if you haven't experienced time travel debugging, give it a shot, and you'll wonder why you didn't have it 10 years ago, because it's really fantastic. And then, of course, there's immutability, and immutability goes hand in hand with functional programming. And a lot of people, when they come to immutability the first time, they think, wow, this seems really efficient. I'm creating a copy of everything, really? All that memory, all that copying, it seems very unnecessary. But there are a couple of things to keep in mind. You're not actually copying everything. You're only copying the things that changed. The other structures stay the same. And then also, this is really JavaScript's strength. Identity comparison is fast and it's cheap in JavaScript. So most people, when they sort of switch to an immutability architecture, they find increases in performance. Now, like everything, you can make a dog-slow immutability architecture, and you can make a dog-slow mutated architecture. So there's always a way to make something slow, but don't be afraid of immutability because you think it's going to make your application slower, because it's not. I think the natural safety net it provides really gives people a platform for experimentation. If you know that you can't actually change anything that exists, you can only create a new copy of it that's modified, then it encourages experimentation that you might not otherwise feel comfortable with. So I think it's really great for beginner programmers as well. All right, and then lastly, I want to talk about choosing your stack. And as you can probably tell, my favorite is React, but I'm not here to tell you to use React or anything else. But I do want to offer you a a framework for thinking about choosing technologies and choosing stacks that I borrowed from Ryan Stevens, whose presentation at Node Interactive 2015, I think, really informed my thinking. So I want to share that with you, and I did get his permission to sort of modify and share this. I'm going to use the example of Angular and React. This is my opinion about it. You can take it for what it's worth, but don't throw out the framework because you disagree with my opinion. So Ryan said, we can think about technologies on these two axes. On the vertical axis is sort of the objective one. You can say a framework or a technology or a tool is flexible or it's rigid. There's either a prescribed way to do things, or it's like, hey, we're just offering a really minimal API, and you can do it however you want. So that's the vertical axis. And then on the horizontal axis is our perception of the technology. Do we perceive it to be simple, or do we perceive it to be complex? And what's really interesting about this framework is observing the differences between what a junior developer is going to think and what a senior developer is going to think. And again, this is my opinion about the difference between Angular and React. The reason I said React plus everything is, of course, React is just the view layer, so you have to think about routing, you have to think about persistence, and use other things. So I'm going to bundle all that together. A junior developer will look at these two technologies, and they'll say, well, Angular, there's documentation that tells me how to do X. So, there's a page in the how-to about how to do routing, about how to connect to persistence. And so it's all there. It's all provided for them. So it seems simpler, even though Angular, of course, is a large, complicated, robust application framework. To the beginner, it seems simpler because there's a way to do everything. React, on the other hand, they're saying, hey, we got this really tiny little API. Go do amazing things with it. And so the beginner developer may be a little more confused or unsure about how to do things. What's really interesting is you look at the senior developer's perspective, and this is my personal opinion about the difference between React and Angular. We look at that rigidity. I look at Angular and I'm like, man, what if I don't want to do things the Angular way? It gets in my way. I feel like all that prescription gets in my way, and that's what I love about React is it gives me the freedom to do anything. So I put these in different quadrants. And the point here is not that, I'm not trying to make relative value judgments about senior engineers versus junior engineers. We all start somewhere. We're all on the journey. But what I do want you to take away from this is think about the composition of your team. Think about the junior developers and the senior developers, and think about the technologies that they're using. Are they rigid? Are they flexible? And using that framework, think about how you're going to perceive them versus how the junior developers are going to perceive them, or the other way around. And the takeaway here is if you're using a technology that's really flexible, React, for example, what you should be thinking about is giving those junior engineers a little more guidance because they may feel a little more lost in that particular technology. Whereas it's very rigid, they may be like, oh, I know exactly how to do this because it's right there in the documentation. So I really think this is a great framework to think about things. I highly recommend you watch Ryan Stevens' talk. It's there online. I linked it in the YouTube, and it's in the notes for this talk. So please do check that out. I think I'm going to finish up 2 minutes early, which will be a first. So thank you, and I will take any questions now. No questions? Okay, thank you very much.